Hi friends, welcome to the ninth number lecture of Odisha SSB lecturer physics solutions. Okay, so in our previous lecture we had completed up to the 40 number question and this is the 40 number question and let's start this lecture from 41 number question. The 41 number question is asked about for a Gaussian wave packet whose peak is traveling with a velocity v naught, we have to find the width of that wave packet where alpha beta are constant. Now if you see the options, okay, there is one term is missing here. What is that term? Let's see the solution. Here this term is missing. This term is del x at t equal to 0. That means the initial width of that wave packet, that is the Gaussian wave packet, is missing here. Okay, so that's why this question is a grace mark question. That means irrespective of the student has attempt or not attempt this question, full mark is given to all student. Okay, this is a grace mark question. Now coming to the 42 number question, the question is asked about the it is given a wave function. This is the wave function. Okay, 1 by root 2a, and you will see that it is obvious that it is a plane wave, and that plane wave is terminating between minus a to positive a. That means it is present within this limit. Okay, this is a plane wave. That means what is the average position of this particle? We have to find that. You remember that for every this type of plane wave, the average position is 0. Now how can you find this from in a mathematical way? Okay, if you see the solution, this is the solution. The average position is psi star x psi dx divided by that normalized term, because we don't know whether the wave function is normalized or not, so we divided that term in the denominator. So uh, if you see psi star is the complex conjugate of that main wave. Okay, so that exponential term, that iota term minus iota, and this plus iota will be cancelled out, and the denominator also, these two term will cancel out, and if you solve those in this process, you will get 0. Now coming to the 43 number question, the question is asked about the wave function of a particle. It is given the wave function of a particle as a psi x equal to root a e to the power minus I a x. It is also a oscillating wave function, and we have to find the probability between these two regions, 1 by 4a and 1 by 2a. How can you find? Just simply put the formula of probability. Sorry, probability. That is the inner product of psi. So what will it give you? This will give psi star psi dx, and you put the limit from upper limit to lower limit. Okay, and you will solve. Okay, again the imaginary two term will cancel out because those are complement to each other. Okay, so it will be like this, 1 by 4. Okay, now coming to the 44 number question. The question is the question is given a wave function. That wave function is this. Okay, and this wave function is present only within the region of minus a to plus a, and in other regions the wave function is 0. That means that there is no probability of getting the particle, okay, outside this region. So what can you find? We are asked to find the expectation value of the momentum. So simply put the formula of momentum expectation value and integrate it from minus a to positive a. Why we are integrating? Because the particle is present in this region only. Okay, so if you make the complex conjugate and you multiply that complex conjugate with that, but before that you have to differentiate with respect to x, because the momentum operator is present before the wave function. So you make that, do the calculation, you will get 0. Okay, you see the solution. Okay? This is the procedure. The actual easy question. Okay, now coming to the 45 number question. The question has given a electromagnetic, the question has given that a particle is moving in the electromagnetic field. Okay, and the Hamiltonian energy is given like this: P vector minus E by C vector potential with it is also uh, dot product with the same quantity. divided by 2a plus e5, and it has asked to find the correct relation. How can you find? Just do the dimensional analysis and try to utilize your common sense. Okay, if you see the option A is d by dt of r vector. D by dt of r vector means what? It's a velocity term, and if you see the RHS side, this is a momentum term. So it cannot be equal because there is no mass term here in the left hand side. Oh, okay. In the LHS side, there is no mass term, and in the right hand side there is a momentum term. So how can be it equal? Both are equal. So both sides should be same. Okay. So this option A should not be equal. Should not be correct. Now coming to the option B, you see that there is a differentiation of with respect to time to the momentum term. This is the new generalized momentum. Okay. P vector was your previous, that is the old generalized momentum. But due to the particle is moving inside the electromagnetic field, this extra term is subtracted from the old term. So this whole term is the new term. So it is differentiated with respect to time. And when a momentum term differentiated with respect to time, what will it give? It will give the force term. So it is denoted as Lorentz term, Lorentz force. Okay, why it is Lorentz force? Because the particle is moving in a electromagnetic field, and whenever a particle is moving in an electromagnetic field, it will experience a force. That force is known as Lorentz force. Okay, but if you see the option C, there is no p vector. There is only present, this p vector is present, and there is no minus. There is no present of this term E by C a vector. Okay, there is this term is not present, so that's why this relation C is also a incorrect relation. And if you see the option D, this is again d by dt of r vector. That means this is also a velocity term, but in the right hand side, this momentum square is present. Momentum square by v, or momentum square by m is not a velocity term. Okay, it is a term of kinetic energy, or in the term of energy, in the dimension of energy. But in the left hand side, there is a dimension of velocity. So D option cannot be equal. So option B is the correct relation. In this way, you can find the correct answer. Okay, thank you.